Strategically speaking, nano cutting-edge technologies have been the focus of so many industries and has a lot of research potential in academia as well. To be able to relate to our presentation today, take one of your hair and look at its thickness. 1 nanometer is 0.00019 of this thickness. Now we are in the first quarter of 2012. 5 years ago, Dr. Dunn and other Cranfield scientists invented a nano light-emitting diode device. They initially developed this technology for smart dashboards in cars. It can be used for displays, monitors, TVs, and mobile phones, which is our focus today based on morphology. From the pioneering works of McPherson in 1973, who identified nanometer-sized features, to the advanced work aimed at manufacturing nanostructured particles, researchers have been involved with them for more than 3 decades. Later in 2010, Zinn and Associates came up with an original coating strategy using a type of nanocrystalline powder. Vivek and Rajendra thought of a green and sustainable approach to nanomaterial by focusing on developing a strategy of using microwave heating with nanocrystallisis. Even in outer space, Romano and colleagues of Acta Astronautica came up with the idea of nanosatellite constellations. They pointed out that communication strategies must be adopted for data downloading. They presented interconnection strategies for the usage of a data relay satellite. Lee et al. Devised an integration strategy for an assembly of nanotubes in photoresist-derived glass-like carbon microelectrodes. And February 2012, Key and fellow researchers came up with a universal strategy for fabrication of nano assemblies. Stay tuned and you will find this program informative and enjoyable, not only for better lives of individuals, but also for businesses that can benefit from these breakthrough technological promises, achieving their missions beyond their visions.
As mentioned on a journal by Strategic Direction, we are never too old to learn. Keeping this in mind, Nokia Research Centre, United Kingdom and University of Cambridge's Nanoscience Centre joined hands and started their study of nanotechnology being implemented into the world of IT. Riggs states that the proliferation of computer technology has ensured that gadgets play a significant role in our daily routines. They are used at work, home and during playtime. Nokia and Cambridge therefore present Morph. Is a concept demonstrating some of the possibilities nanotechnology might enable in future communication devices.
Let's move forward with the possibilities that Morph can enable. Daphne and Anjani Kivioja, researchers on nanowire FET-based molecular sensors at NRC Cambridge. According to them, Morph can interact with surrounding environment on nanometer scale and is capable of providing key information for anything from temperature change to pollution. Nanosensors are used in this purpose for transmitting the local data, global connection and community, returning the context-relevant data in real time, empowering the users to examine the environment around them in completely new ways. Nanostructure can also enable robust chemical and biochemical sensing. This will help us to make the key decision that guides our daily actions and ultimately can enhance our health.
Michael Gradel, a Swiss scientist, invented a new kind of solar cell that uses dye-molecules and titanium oxide. This enabled manufacturers to place highly efficient and versatile solar cells in flexible plastic cells, which allow them to charge the phones. The surface of the Morph can become a natural source of energy through its covering of nanoglass structures that harvest solar power. Nanomaterials enables solar energy on large scale.
We can see a water droplet that beads on lotus leaf. It is due to the hydrophobic nanostructure, and this principle is known as superhydrophobicity. The surface of the Nokia Morph is similar to this. According to Nokia principal scientist at Nokia Research Centre, Cambridge, the nanostructure coating on the mobile phone traps a thin layer of air on the surface. The water is on that thin layer and becomes very mobile. Keep the surface dry. We are interested in this feature because if you drop your mobile in sink or bath next time, there is a good chance that it survives.
Transparent resistive random access is used for transparent electric surface of Morph. By integrating CRAM device with transparent electric components. A total see-through embedded electronic surface is developed. As mentioned by Harrison Rainey, Morph contains nanoscale electronics, which becomes invisible to human eye.
It can be difficult to imagine exactly how this greater understanding of world of atoms and molecules has and will affect the everyday objects we see around us. But some of the areas where nanotechnologies are set to make a difference already. As Dr. Ignat Grace described, by using nanotechnology, the atoms of molecules but particles can be rearranged, and that leads to the tiny but stronger and flexible products. As Dr. Clive Roberts said, nanoscientists are now enthusiastically examining how the living world works in order to find the solutions to the problems of the non-living world. The way marine organisms build strength into the shells has lessons to how to engineer the new lightweight, tough materials for cars. If the nanotechnology comes to play to revolutionize our lives, this will definitely form our future, because they are in every cell of the body, turning food into energy, fixing damage, and etc. Humans are already a masterpiece of molecular nanotechnology, as studied by the Professor Mark Miller, the Professor of Nanoscience Center at the University of Cambridge. The future of nanotechnology has already begun, and the coming years will be the age of nanotechnology. It will take us into the star times and beyond the stars.